constant in Z. So we can say that our K prime of Z is 0. Now, if K prime of Z is 0, then K of Z is a constant. Now, we're going to substitute the K prime of Z into a constant so that we get the final value of F. So F is going to be equal to, what is F equal to? Y squared sin X plus Y squared sin X plus Y e to Z, Y a to Z plus a constant C. So this is the value of our F. Now, once we are able to get a certain F, that when we, so this function, when you differentiate, we're going to get the original function. Then it tells us that the function is independent of path. Now, if it is independent of path and you want to find the integral of F dot dr, then you know that you're going to evaluate the final of the value of the function from the final F of the end from the beginning. So this is easy to do. The integral of this function would be F of the end point minus F of the initial point. Okay. So that is how we obtain. So we've done all this already. Hence, it's independent of path. Now, once it's independent of path, the value of this is going to be equal to, yes.
So please, I want to get this clear. So does it mean if it is two terms, I mean X and Y, for the first one that we did, so it means that you
Yes.
differentiate the first one first, and then you get a function, and then you integrate to get the other term.
Yes. Then you
Then
compare
after
it. And oh,
then you compare, then you differentiate again, or you integrate to
you
get
integrate,
the
then you
value.
compare it with the next term.
Okay, but 3D thing you integrate, three dimension you integrate first.
No, it follows. The only difference now that there is a Z term. So you will need to find the value of the Z's also. So you see, it's like this. You have a function F. Now, if this function is equal to the gradient of F, then it should be like F xi plus fyj plus fzk. Okay. So what we are actually finding, the value is the fact that we want to find the F. Now, to find the F, if you take the first term here, that first term is x. So if I have fx and I want to find f, I'll have to integrate the function with respect to x. Then I'll get the f. Now, if you get this f, you can, so you have certain function f. Now, this f here, I'll differentiate with respect to y. Now, if you differentiate this with respect to y, you'll be getting the second term. So you compare these two terms. Now, as I've gotten these two terms, maybe the difference between the two of them is a certain function, say p of y comma z. Now, so maybe there is a term that they are the same. Then you can compare the two of them. That, okay, if I differentiate this f that I've already obtained, and this y was also given, f of y, f sub y is given, then the difference is that, so I can say that this p of yz is this other one which is missing. So let me use the just previous example. Now, initially, we're given certain f. Now, when you take the first term, we'll say that, oh, the first term is fx. So if I want to get the value of f, I'll integrate it with respect to x. But there will be a constant term. Now that constant term will depend on the other variables, which is y and z. So now let me differentiate that function with respect to y. But if you differentiate with respect to y, you have 2y sine x plus g prime, because there's a y in this one. And if I differentiate with respect to y, it must be g prime. But in the problem itself, I was given these ones that sine 2y sine x plus e to z is my fy, according to the question itself. So I can say that, oh, then these two are also the same. Then the missing term, because these two have been given already. So one is subtract, you get the same. Now the g prime is e to z. So if I want to get g, then I have to integrate this function with respect to y. Now, if you integrate this function with respect to y, you have y e to z plus another constant which should depend on z only. So at this point, this is my g of, then I'll substitute it back. What is f? F is this value plus g of y. But I now know that g of y is this thing, so I'll substitute it for all of this. Now, at this point, I have the f. So I have two terms for f plus a constant in z only. If I differentiate this function with respect to z, I'll have this. But from the original problem, we know that the third term is fz. So I'll compare this with the third term. Then I see that, oh, these two terms are here already. But the k prime, there's no term for it, so it should be 0. Now, if that one is 0, k prime is 0, means that k should be a certain constant. Then I'll replace back into the f. What is f? F is the first two terms plus k. Now I've obtained that my k is a certain c. So I can replace it and say that the f is all this now. Now, because I'm able to write it as the gradient of a certain function. Now, this function, if you differentiate it, you're going to get, with respect to x, with respect to y, with respect to z, you're going to get your f. Then this function is my f. Now, once you're able to write this f as the gradient of a certain function, it means that the function f is itself independence of path. So to get the integral of this function, I should be able to say that it is the endpoints, the difference between the endpoints, the f of b, that's the final point, minus the initial points. Okay, so that is what we just did. And yeah, Dr. Ampia, your hand is up.
Sir, please, is it a rule for you to replace the G and Z with the E exponent 2f? Is it a rule?
I said G or
This
G.
one.
Mhm.
Division of y comma z equals the 2 exponent e exponent 2z. Is it a rule?
No, you have to integrate it with respect to y. So what happened is that, you see, from here, you know that
This one.
the fy,
Yes, sir.
after you have differentiated the first f that you had, this is the first f. There is a function which involves y and z. When you differentiate it, you have the first one. So this one here is the differentiated one. This one here is the given one from the problem. So you are
Okay.
going to compare the two. It was in the
Okay, sir.
question. So when
Okay.
you compare the two, you see that the g prime is e to z. So if you want to get the g, you integrate it. So from
Okay, sir.
between here and here is integration. Now, when you integrate the left hand side, you have g of y. When you integrate the right hand side with respect to y, you have y is e to z. But because it depends on both y and z, there should be a constant in z.
Okay,
All right,
sir.
so having done this one now, we'll substitute it back into the first f. So we'll put this one here. So y plus k. Now, with this that we have obtained, we need to find the k of z. So we'll differentiate the function again with respect to z. So we'll go back to the problem and take the third term, that is the one which has the k on it. You see that when you differentiate it, you have this one, but the function that was given is 2y to z, which means that the k prime is 0. Now, if k prime is 0 and you want k, you integrate it, k will be a constant. So we're going to replace it back into the g. So for this k, you put c. Now the g, and then you replace everything back to get the final f. So the final f would be this function. Now, once you're able to write the f as a gradient of a certain function, then it tells us that it is independent of path. It is independent of path means that f of b minus f of a. Okay, so that's the stepwise solution of it. Hannah, you have dropped your hand. Okay, that's fine.
Yes, sir. Yes, sir.
So if you want to evaluate the integral, we're going to take the g value we have, the f value, which is y squared sine x plus y e to z plus c. Then we'll evaluate it first at the endpoint, that is pi over 2, 3, 2. So find f of this one and minus at the endpoint 0, 1, half. You substitute them into it, you're going to obtain this function. So for the substitution, just that where you see x, you put the corresponding value pi onto. So you have sine pi onto, that term will go to 0. And there's no other z. The c, you know, when you do definite integral, the c part goes off. So you can choose to add plus c, but it will still cancel out. Okay. Now let's take one more example, then we'll take a break after this example and come back for some few minutes before we close. Yeah, any more? So let's look at this example. By the time we finish, I'm sure that we should be okay with it. Now, find a function f such that the gradient of f is equal to f. Okay. Now, f is this one. So let's start first with the y squared. Now, if we want a function f that should be equal to the gradient of f, you know that whatever you have there should be like this, fyj plus fzk. Okay. So now, whatever we have there now is fx. So if we want, so let's see what's fx. Fx is y squared. So what we are given first is that f squared, fx is y squared. Now, by this, f will be equal to xy squared plus a certain constant. So I'm going to call it f of, but it will depend on the two other constants, g and z. Now, we'll differentiate this function with respect to y. You have 2xy plus g prime of y comma z. Then we'll go back to the original problem and see what is fy. Now, fy we are given is 2xy plus e3z. 2xy plus 3ez. Okay. Now, clearly, we can see that g prime of yz is 3ez. So then I need to find g. Now, to get g, I have to integrate it with respect to y. Now, if I integrate this yz with respect to y, you have 3y ez. Okay. Then I'm going to differentiate this function. No, so let's substitute it into the f. So it's xy squared plus g. So f is xy squared plus g. What is g? G is 3y easy. Yes. Now, let me mention that I will need to add another function of z. So when you integrate a function, you need to consider the constant. So f of z. So I'm going to add this one. So let me do w of z so that it doesn't conflict. W of z. Now, I'm going to differentiate this function with respect to z. If you differentiate this function with respect to z, the first term will go. Then you have 3y ez plus w of z. Okay, now let's compare this with the third term, which we know already that it should, if it is independence of path, then it should be giving us fz. Now, what is fz? The third term is 3y e 3z. 3y e 3y e z. Is that 3z? There is a 3z. But why did we use? We didn't use the 3z. So over here we should have used 3z. 3z. Okay, but the procedure is the same. So let's continue from wherever we went off. But the procedure is going to be the same. Now, so 3y e 3z plus, this should be the differential of that function. Now you see from here that your w prime is 0. W prime of z is 0. It means that when you integrate it, your w of z will be a constant. So I'm going to substitute this constant for the w. So that the w is c. My f is going to be xy squared plus 3y ez e3z plus a constant c. Okay, so that is the expected. But here they say is k, but it doesn't matter. These are variables. So xy squared plus y e3z plus a constant. Now, once you're able to obtain this function, it means that it is independent of path, and then you can evaluate it. But in the problem, we're not giving any limits to evaluate. So we have just been able to show that this thing here is independent of path.
Sir,
Okay. Yes.
sir, from the slide here, you have
Yes.
YE3Z, but what you wrote, you brought 3 YE. The
Yes.
YE3Z, but from what you wrote, you brought 3, but here there's no 3.
Yeah. So what happened is that what is the thing? You know that from here. So what happened was that there was an error. So from here, now when you compare the two of them, 3e 3z, now this is fy, is this one. Now if I want to get my f, then I'll say that this is 3e 3z. But when you integrate this function with respect to z, you should get, when you integrate this, you have ye3z. Okay, so this was where I went off. Now, you know that if you have 3e3z, so let me go to the end and show you. 3e3z. Now, if I integrate this function, I'm going to have E3Z. Then I'll differentiate the power. Then that will be over 3. So it is going to cancel out to give me E3Z. But because I left out the 3Z at the power over there, that was how come I missed it. But normally it should have been that I should have just YZ like this, YE. After I've divided through by the 3, then it will cancel out, giving me YE3Z. So you see that I even left all the 3Zs in it. So this 3Z should not be here, it should either be up. Okay. And when I differentiate this one, yeah, so but this is correct. So when I differentiate this with respect to Z, we're going to have 3YE3Z, which is correct now. And then when you compare the two of them, you're going to have a constant that you add to it. So you see that they have in the conclusion xy squared plus YE3Z plus a constant. Okay. So it was because I left the 3 in the power over there, it didn't cancel out the 3 that was already there. But normally it should have done that for us. All right. So let us take a 10 minutes break and come back at 7:49. Thank you very much and see you soon. Bye-bye.
Doctor.
Yes.
Dr. Lano.
Present, madam.
Please, this particular one, yes, please. Good morning. Please, this particular one, there's no going crowd.
But this one rather is calculating, it's more of calculations. But if your fundamentals are not of integration and differentiation of general functions, it's going to be exposed over here. But once you know it,
Yes,
you are able to know that if it's independent of path, this is what you test for. Then you progress. But this particular is more of calculations, so you should understand the backgrounds to it before you can progress.
Yes, sir.
All right, so let's take.
Right. Oh, we come back.
Yes.
We'll see.
Sir,
Okay.
please.
Yes.
I want to confirm that after school or after all this learning, which area specifically can this theorem be applied? Is it for teaching or for any field activity? Because the differentiation and the integration, I don't know where exactly is going to be applied.
It's in the class.
Look,
Master, just to confuse the government.
differentiation. You see, differentiation and integration has never been unuseful. Differentiation and integration has always been the base of even the finance of every nation. Differentiation and has been the backbone of every engineering and computing. That is why even this course we have added ICT students, because you cannot
Yes,
do
sir. IT students.
computing ICT without mathematics. Yes, we know, and it was deliberate. It's not like a wickedness, but as part of curriculum, you need to understand these independent of paths. You should be able to differentiate the function. You must be able to find the maximum point, the minimum point. You should be able to find stabilities, so that when you are even doing your computing or your education or whichever field, disease models are gonna.
Because the understanding is not coming. Crack.
Just as Doc said, if the fundamentals are weak, they actually forget.
But this one, they mean
Exchange rate has exposed us.
I'm just
Fundamentals.
For
Even
this last
look at
one,
the
yeah, not only
1 and 2.
we the math people cry are suffering. Then we the math people cry are suffering. That this last one, yeah.
Yeah, this last one, the killer head. I swear. Me right
Hey,
now,
I was so
just one question. I should solve one question and go for graduation. Kuramasa, very easy. The course is just posing more threat to our life. But
The class is not ended. We will go. We are on break, so he will come back later. The one comment on the chat.
Yeah, please. What's the time for the break? Minutes.
He said maybe 10
But bro,
minutes.
please,
it's
when did the class start? Because it seems like you started earlier, right?
Yeah, 6 o'clock. It always starts at 6.
Hey, I didn't know. I
Hey.
thought it was at 7, so I wait.
Oh no, me I
The
just don't know.
online will be from the day we began. Yeah, from the day we began, he told us that the following weeks will be meeting at 6. So for this particular one, it's 6. But the rest, it's 7. No. The class has not ended on him. We are on break.
Oh, okay.
Hey. Oh Charlie,
This one there we have to
So
start
we close.
our juju.
So this one around 8, getting to 9, we close.
Oh, okay.
Yeah.
Oh, please,
This
is there
is
anyone
this is the right
who
time.
understands more so that at least we find then the person will take us through, please?
For this last one, we are just watching the screen.
No, but at least there will be there's somebody who understands something inside. If not, the way me, I'm not seeing anything, Charlie. It's not easy.
Hey, Danny,
Yeah.
what's up?
Lawrence, I've seen you are calling me, but the same phone I'm
I
using
just
for
said
the
here, big free flying pan one better than Mukura. Not fire. Hey, I just student in the master who market one better guy.
What's that? Hey, Charlie, I didn't say that she cried. Hey, I'm wondering.
More wait,
For
Jimmy,
that,
come in.
I
I don't
say, I
get
want to
from
answer.
that.
That's the more.
Oh, this calculus is a really advanced one. It is very, very an advanced
Also,
one.
another better to differentiate your integrity. Are they?
Needing what I'm saying.
Wait, seriously, right now, like just a single question, say the cheapest of all class, say me the means solve crowd, mean grade like
This one, yeah.
They have to temper justice with mercy. If they should go by lie, they will have it.
You temper justice with mercy, crana so on the beer, but cramming.
You didn't do last blocking. You didn't do advanced calculus one.
Charlie,
we did calculus one.
George.
Yes.
It's not about we didn't do this one, but this thing is not just entry. We are not just.
But this last one, I don't know where this concept is coming from. That he has switched off crowd. He's off somewhere crowd.
I don't just. Oh God.
That's it. Hey, Masa, I'm waiting. The BI, the money, but we didn't quarter the money. I don't.
No. We kuranji. We did.
What the man? How are you? I will break.
Yeah.
And
Yeah.
I went off, so I just want to know.
Welcome.
I don't know, record you. You're complaining too much. UCC will begin printing the receipt papers there in advance.
This one, yeah, we have to beg him to give us a tutorial question. So because of
And they were printing the receipt. Charlie.
The IT students, let's get some money for receipts before we write the paper. Why?
Oh, Charlie Henry, with this one, dear killer, I'm off. Oh. I'm just off, light off, boom. I can't see anything. Oh, the previous
After
one.
today, I can't one meeting, but near
I can't meet you. I can't see you. I can't meet you.
You see, the math students are not complaining. It's only the IT we are complaining. The math, they are very much okay and comfortable.
Yeah.
Massa,
For them,
he's shy to talk. He's shy to talk. They're also struggling.
We also complain.
no, you see, Danny Selim is not complaining. We are complaining. Danny Selim is not complaining.
Hey,
That
Masa,
is IT.
Masa, me, I am the number one complainant. If we are filing for a motion, my name will be on top. Ah, brother.
Yeah, recording is going on.
And Mr. Roma, Madam, let us talk on our head. What you can say 300, you have money. Maybe you.
Oh my God. So I don't know where they got the course from. Hey.
the thing is because we are not having time, because family issues and the rest. But other than that, if we were to be on campus, this thing we grab for the whole year.
Yeah, that's what I say. You would have gotten that one person who can at least teach you one question, and you take it from there. You see, the thing is about build up. We are just building on the So if you have missed something previously, my friend, you are just lost forever. You are lost forever.
It's so easy.
You can never understand it.
At all. I thought the thing could be in front of you, but Masa, you just be looking at it. Oh.
Oh God. Anyway, the name alone should have ring something in our head for us. Advanced.
Yes, so it's not easy at all. It's not easy.
Calculus, I know calculus to just be calculus. We started that further calculus has come inside. I say, oh, this one there, that's the last thing we are doing. Further there, the next year advanced one. You see, I feel the kura. Last one is advanced two. I can't. Hey boy, that's true too. Ko college ko calculus if you see any I am answer be na any number. Hey, jokers.
All right, thank you and welcome back. So yeah, so the break, we're asking why do we need this course, but maybe that will be for after the course you would understand, you would appreciate some of these things when you start your specialities, maybe masters and other courses. You understand that these ones are fundamentals. So if your differentiation and integration at any level was not good of the further calculus was not good. It's going to be seen here. All right, now my screen is off. I understand. So we are going to progress with a little bit more. Please, those who just join us, you should be guided that for today and for the Sundays, we start at 6 o'clock. We end around 8:39. And then possibly we may have to also meet on this Thursday, because last week Thursday we met. At least today I was able to do a quick recap of what we did, but when we met, the number was not encouraging. So this Thursday we will be meeting at 4:30 to 5:30, thereabout. Now let's move on to Green's theorem. In advanced calculus, one very important theorem that we know, which theorem that in mathematics is a Green's theorem. Now, the Green's theorem is the ability to find line integrals in a simple closed curve or a simple closed path. And it's able to help us to do a lot more line integrations than the ones we have done earlier. So once you're able to formulate the Green's problem, you are able to get exactly what you want, and it's faster and it's also easier. All right, so now in stating the Green's theorem, use a convention that the positive, you know from basic trigonometry that when you are measuring angles, you measure angles in the counterclockwise direction. This is positive. And when you measure it in the clockwise, then it is the same angle, but it's going to be negative. Okay, so if you we use convention that the positive orientation of simple closed curve C refers to a single counterclockwise transversal of C. Okay. Now theorem, we let C be a piecewise smooth simple closed curve in the plane, and we let D be the region bounded by C. If P and Q have continuous first partials on an open integral or on an open region, then the integral of P dx plus Q dy is equal to the double integral of Q dx minus the P dy, all of them dA. Now, when you see this dA, it tells you that you need to consider also the Jacobian. Last week we mentioned it. So the dA means you have to transform it into both the x and the y. Now it can mean the x and the y if r is 1. Okay. Now the notation integral of P dx plus Q dy is used to indicate that the line integral is calculated using the positive orientation of the closed curve C. Okay. So when you see this sign, the integral over a closed, so this one is a closed interval, then the region is the C. Right. Now, by the Green's theorem, let's take an example. So first, you take the Q, you differentiate with respect to X. This problem. Can you hear me back? Hello, please, can you hear me?
Yes, please.
Please, can you hear? Okay. All right. So
Yes, we can hear you.
the internet
I can
won't
hear
talk.
you.
Just a bit fast. All right. So this formulation here is what we call the Green's theorem. So you to evaluate the integral of e dx plus q dy, you find the double integral of the q dx minus the p dy dA. All right, so let's just write it out here. Now the integral is p dx plus q dy will be equal to, now the right hand on the integral of p dx plus q dy will be equal to, now the right hand will be the double integral over a certain domain D of, we're going to differentiate the q with respect to x partially, minus you differentiate the p with respect to y partially, and then over the domain.
So please, you have written
So
the partial derivative of Q with respect to Q.
with respect to y. Is respect to y. So this should be the y. And this should be the x. Okay, so this is a very important formulation. So a qx minus py is qx minus py. Qx minus py in a. Okay. So once you have this formulation, you should be able to evaluate that line integral in that closed region. Okay. Now, example. We want to evaluate
So please, we can't hear you. Your network, please. Or it's from my side.
okay.
And your screen too is not showing. Okay, it's now showing.
Yeah, it is back now. All right, so yeah, normally around 8 o'clock there will be a switch over. So I'm sure from now on we should not have that problem again. Now we want to integrate x4 dx plus xy dy over this region. So there is an x region and there is a y region. So we're going to formulate the Green's problem. Now the Green's problem says that, so let me pick the problem first. The problem is x4 dx xy dy. X4 dx plus xy dy. So we want to integrate this over the closed loop. Now, so first, oh my goodness,
This one, the network is too bad.
all right, it's back now. I'm not sure why the internet is giving this challenge. All right, please, can you hear me back?
Yes, sir. Yes, please. Yes, sir.
All right, please, can you hear me?
We can hear you, but the screen is not showing.
The screen should be showing.
No, it is showing.
I think
The screen is
it's not
showing.
The screen is
showing.
It's showing.
This one, the noise is not good at all.
All right, so I had to go up and rejoin, but I think that now it should be working. As many people can see me. Who can see the screen? It should be working now.
Yes, it is showing.
Yeah. So let's progress with the Green's theorem. Now, the Green's theorem says that if we are integrating over a closed region, a function m dx plus n dy, you differentiate the p with respect to x minus the q with respect to y. So first, let us, now what is our q? So it's xy. So this will be equal to the double integral of, now when you differentiate q, so this is q, and this is P. Now, we are going to differentiate the Q with respect to X. Now, if you do that, you know that you're going to have Y minus, then you differentiate the P with respect to Y. When you differentiate X4, you get 0, dA. Now, this dA in this case is going to be the X, dy, depending on the region. You can do the Y dx or the X dy, whichever one. Now, what is the region? We know that from advanced calculus 1, the region is such that the Y value is taking values from 0 to 1 minus X. Is a function which depends on X. And then the X values is from 0 to 1. So first, we need to integrate the Y first before we now integrate the X. So to do that, we would have, so currently here we have to do the Y first before we do the X. Now the Y is taking values from 0 to 1 minus X. And then the Y is taking values from 0 to 1. From 0 to 1. So we would obtain the whole integral from 0 to 1 minus X, 0 to 1, Y dy dx. So we have formulated the Green's problem. So somebody will ask that the advanced one, where will you use it? In Green's theorem. So you need to know that we will integrate the Y first before the X. That is advanced 1. Now at this point, if you integrate the Y, you have Y squared over 2. Then you put the limit from 0 to 1 minus X. Then you now integrate it from 0 to 1 with respect to X. So if you do, you have 1 minus X over 2 all squared minus 0. When you put the 0, it will still be 0. Integral from 0 to 1 dx. Now we want to integrate this function now with respect to X. So you can expand that. You have 1 minus 2X plus X squared. And you can take the limit out from 0 to 1 dx. So that you integrate X, 1, you have X minus X squared plus X cubed from 0 to 1 times half. And you put 1 in it, you have 1 minus 1 is 0, and then you have 1 over 3. 1 over 3 times 1
Hello,
over
Doc.
2. That is 1 over 6. Because when you put the 0,
Hello, Doc.
yes.
Please, I thought from
Yeah, we can
advanced
hear you.
one. Yeah, from advanced calculus 1. When we do the first integration, we substitute. Okay, so that is what we have substituted, and then
Yes,
we are integrating from the limit 0 to 1. Okay, okay,
yes, 0 to 1, yes. The second
okay.
X.
The second one. Okay.
So you expand the numerator, you have 1 minus 2X plus X squared. Then the half will go out. I want to integrate, you have X minus X squared plus X cubed over 3 from 0 to 1. And if you do, you should have 1 over 6. Okay, so All right, please, can you hear me back? Today, my internet is not so friendly.
Yes, please.
Okay, so that's the required solution. Now let's look at example 6. Want to evaluate 3y minus e sine x dx plus 7x thus ey, where d is a region enclosed by d's. Now, r takes values from 0 to 3, and theta takes values from 0 to 2 pi. So, if you formulate the Green's function, you differentiate the second term with respect to x. Now, then you differentiate the first one with respect to y. So you see that over there. Now, at this point here, we want to do the differentials. Now, doing the differential, remember that when you differentiate 7x, you get 7. When you differentiate the y part, you get 0. Then if you differentiate the right-hand side, you have 3. The e sine x will be 0. So that you have 7 minus 3. Okay. Now, the region we are given is polar. So you see that your r, comma theta, your r lies between 0 and 3, and your theta lies between 0 and 2 pi. So this is polar
Hello,
coordinate.
Doc. Hello, Doc.
Yes.
Hello, Doc.
Yes, hello.
Sorry, because of the line breaks, which means that when we want to integrate, we switch the function of x for that of y, and the function of y for that of x. That is.
I didn't get your question.
Hello. Yeah, the original function that is given, you know, the 3y e sine e exponent and x was for that of the function of x, and the 7x plus y raised to power 4 plus 1 was for y. But when we want to integrate, we switch that of y for x and that of x for y. Is that the situation?
You differentiate the y part, the second part with respect to
For
x,
and you
minus the first part,
yeah, that of y for x, yeah,
with respect to y.
Okay, thank you. So we switch parts.
Yes. So you differentiate this second term here, this second term here, the one that has a dy, you differentiate it with respect to x. Then you differentiate the first part. Okay.
Okay, it's clear now. Thank you. The line is breaking, but it's clear. Thanks.
All right. So using this very example to demonstrate it, we are going to differentiate this part here with respect to y, with respect to x first. Now, if you differentiate this thing with respect to x, you have 7. Can you hear me?
Yes, Doc.
Please. Yes, please. I'm following. Yeah.
Okay. All right. Then minus, we'll differentiate the first part here with respect to y. Now, when you differentiate this with respect to y, you have 3. So the function will now reduce to 7 minus 3, which will be equal to 4. Yeah. Hello. Please, can you hear me now? Um.
Yes, please, we can hear.
All right. Please, let's take a 10 minutes break. I'll see if I can rectify the internet issue, and then we'll come back with some few more examples before we close. Good morning. We can hear you.
All right.
All right. So let's take a 10 minutes break and let's see if we can resolve this problem.
Harry? Hello? Harry? Harry?
We.
Ogbe is gone. Okay, the class has ended.
No, it hasn't ended. Doctor is having challenges with his network, so he says we should give him some time. He's rectifying it.
Thank you.
Danny Slim.
Yeah, Prince.
Also, MAT program no so much as here na.
Yeah.
MAT program bi na almost send almost say concessionals di almost so pursue your friends MAT na show your interest.
MPhil. Maria Medalada.
Aha. Okay.
Ma accepting.
One accept.
Meti so mbe share see next month 16th.
Next month.
30th of this month.
Meti next month 16th.
Next month on Bajasi.
But I say what you now or graduate answer. Last year for a bit brave failure. If you actually a trauma, I see moment to me.
Yeah, being no correct. I don't know when you have concession now. Wow, I graduate here. What confirming admission on your portal? Only certificate here. They will not give you the concession. To be
last year, if you are your margin, so more than twice. If you actually a trauma, I see no matter the out now.
Make I say. The concession is given to students who have already completed and they have certificates. So you go and confirm the admission on your portal. And then you'll be given the concession. And this are
okay.
Lawrence.
Yes, sir.
Was it our seniors last year?
Last year for I'm a party about console yes and call Yebi. Maybe it's not last minute, you know, when you're IC. He just wrote the IC with us, network computing.
Oma man concession to send your mama a day na day.
Someone to me, no program no when you're throwing the things obey. But Omokwa graduation when to me and graduate because almost when you're IC. I'm saying online quiz when to me and and she must IC 7 years. I want to watch check you. When him say last year, let's quiz that you try, you know. Was it pedagogy or what? I'm trying to IC. I have to consult them. Quiz I'm about to know what trauma sign. Almost many IC. Masa, the got too much in a matter, man.
And the end, you're dealing with young for gentlemen, and almost sunny.
The session is being recorded, oh, please. The session is being recorded, please.
Okay.
I see proportion in here. Or why am I in checking? It was school or it was only free.
Wow. I will try. Oh, and I'm I see.
Maybe sure quiz one not entered. Aden. And you have to number screenshot me quizzes name now go and I'm the sending or more. A consult your man, I'm here no more to send a man. This a man trying to say it was your to graduation. I come this next year.
Hey. If you say be accept concession, I mean, besides say how far.
That concession accepting there, and also who could create school fees now? Who could create school fees now? Some more creative portals in every.
I'm creative portals. Utia ane do aka.
Utia ane amount admission index number registered number.
Now, yes, you bet me I MSc no. You bet me I MSc.
And office near
17,000 plus for the MPhil.
170 million.
again. Let's take you.
All right, so I think that is back now. I'm not sure if we can see the screen.
Yeah, we can see, please.
Hello, please, can you hear me?
Yeah, we can hear you, but your screen has gone off again.
Yeah, so it's quite unfortunate. I'm not able to continue. So I would rather. All right, so I'm rather going to schedule it for Thursday, just as we did for last week, at 4:30 in the dawn to 5:30
All right.
thereabout. Next Sunday, I'm sure that if we do, we could be able to finish the entire course. If we are not able to finish on Sunday, we'll meet on Thursday again. But I'm supposed to do only on Sunday, but we can also add a Thursdays. So please, I would suggest that there are tribe problems behind every week's slide. Try as much as possible to be familiar with the story. Try and solve them. Try and make meaning out of the problems and solve them yourself, so that it's easier for us when we meet on Thursday. So on this note, I'll have to call up the class and we'll continue on Thursday at 4:30 a.m. when we come. Thank you very much. 4:30 a.m.
Thank you, sir.
Thank you very much. 4:30 a.m. Thank you so much. Thank you very much. 4:30 a.m. Thank you so much. Thank you very much. 4:30 a.m. Thank you so much.
Yeah, Miss Rebusa, made message, almost sending, as a text message and through our portal.
Arewanya bi.
To me, who the antina may busano.
SMS wanya bi de ndi omo ma on.
Okay.
Concession, no, you have to go and confirm from your portal first before someone message you. It doesn't come automatically. You go to your portal over corner or my confirm admission. Then you go and confirm, and then the system will automatically.
Portal and emphasize.
When you open the portal and go through the menu, you see one of the columns where you are supposed to click and check your statement. Down, you see that confirm. But this time, no, I don't think it is there.
And I made a man cover be a mother man.
Really?
I mean, man cover be a clan. I mean, the okay crab in ye be done. I mean, portal home you call her timetable.
Okay, so go and check.
So I think that I think that for admission purposes, you need to have a minimum of 2.5 for you to get a concession. So if probably you don't have if you don't have a GPA of 2.5, you may not have had the concession. I think so.
Okay.
Hello? Hello, Harry.
Hello.
Has the class ended?
Let's talk back now.
Oh, okay. Okay.